putting it all together, solving systems of equations. So far, during Chapter 5 and in Unit 3, we've learned 3 different ways of solving systems by using graphing, substitution, and elimination. Let's look at each one. For graphing, you usually want to have the equations written in slope-intercept form, where you can clearly identify the slope and y-intercept. In this case, I could graph both equations. First, I'd start on -1, I'd go up 3 across 1. For the second equation, I'd start on -5, go up 2 across 1. Hopefully, these 2 equations will intersect at a point. That's the solution to the system. You could also solve this problem using the substitution method if you don't have any graph paper by substituting where the y is, 3x minus 1. The second type of solution that a second way of finding a solution was substitution. Substitution is really good when you have one of the variables by itself. You simply take out the y in the second equation and substitute that with 3 minus x. You rewrite the problem and solve using distributive property and combining like terms. So substitution is the best when you have one of the variables by itself. Elimination is great when you have the 2 equations written in standard form. Standard form is when you have the x and y on the same side of the equal sign. Sometimes you're going to have to multiply one or both of the equations in order to eliminate one of the variables. In this case, I multiplied the first equation by 2. As you can see, I can eliminate, actually in this case, both of the variables. Let's see what happens when you solve this problem using elimination. After we learned how to solve the problems, we learned about 3 ways to represent our solutions. One solution is when you have an x and y variable at the end of after solving your system. In this case, I used elimination to eliminate the y's, and I found that the solution was 2, 3. Let's see if you get the same answer when you solve this system. If you get one solution, you have a variable and a number. No solution occurs when both variables cancel out or when you graph and you get parallel lines. When the 2 variables cancel out, you're going to get a number that does not equal another. In that case, there's no solution to the problem. When we graph these, we can see that these both have the same exact slope, which is 2. The y-intercepts are different. Because you start on 2 different points on the y-axis, and you have the same rate of change, which is 2, or the same slope, the lines are always going to be parallel and never cross. That's no solution. Infinitely many solution, that occurs when you create the same line for graphing, or all your variables cancel out and you're left with one number that equals itself. In that case, there are infinitely many solutions to the problem. I can put in any number for x and y, and these 2 equations will always equal each other. Let's look at how to graph these. In this case, you're going to both of them are going to start on the y-intercept of 2, and it looks like they might even have the same slope. Doesn't 6 over 2 equal 3? Let's see. If I go up 3 across 1 or up 6 across 2, it's actually going to be the same rate of change, therefore creating the same slope. So I want you now to go back, and I'm going to put these problems on Google Classroom, and you're going to solve these 6 problems. Hopefully you're able to find the same answers that I did. We'll go over them tomorrow in class. Please submit your solutions tonight. Thanks for watching.